Hello, hello. This is Riemann Sum Part 2, and I've got to tell you that this video might be the nastiest video that you've ever heard because I'm going to be making some very disturbing sounds from my illness. Please don't get sick. That's just a cough. That one's not bad. Okay. So let's go back here. Oh, let's clear that. We don't want that. We do not want that. Okay. This is the big finale. This is the thing that's going to get us to our next big idea. It's really exciting. I wish I was there in class to teach it to you because it's a really cool thing that that the mathematicians kind of assembled here to find the exact area between the curve and the x-axis. I'll stop stalling. Here's what we got. We can generalize what we have now. We have n rectangles for some function f of x from a to b. Okay, so these two parts right here, from a to b and n rectangles, I can actually determine the width. Oh goodness. The width of each rectangle. And what that means is if I am at one point here, A, and another point here, B, and I have a whole bunch of rectangles here, okay. Well, then if there are rectangles all... Come on, Blaine, you can do it. If the rectangles all have uniform width, so let's keep that in mind, and they will in your case. If they have uniform width, for now they'll have uniform width, of each partition, well, I could take B and subtract it to A. You could do B minus A. And then to find out the width of each one, to make them all the same width, to make all the rectangles the same width, I divide it by how many rectangles I want. That's kind of what I did in this last one. Oh, did I clear that one? That's kind of what I did here when I did B and A and divided by n, right? Because n was 2, B was the end point, A was the left end point. So we kind of did that already. That's the uniform width of each partition, B minus A over n. Okay, the height of each partition. If you're not sure what partition means, we're talking about rectangles. Okay, the height of each rectangle. Well, that's going to be a little bit tricky. So let's go here. Let's say that we have this rectangle here. Oh God, I can't believe I'm burping in this video. It sounds horrible. Now there's two ways that you could actually write this. I'm going to show you the less complicated way. You're welcome to try the more complicated way afterward. Take a look at just this red point. You may assume that each width is B minus A over n. Here is A, here is B. B and A are the endpoints for the right and left respectively. Well, the problem to get the height for each rectangle is going to be the height keeps changing. It never stays the same, which is kind of a problem. But we can use some math to be able to find a formula, a general formula, for the height at every single rectangle, which is kind of cool, actually. So we'll use right-hand rectangles for this because that'll be easier. Again, left-hand rectangles are possible, but a little bit harder. And here's what we're going to get. Our height is going to be, well, let's see. How do I get from here to there in terms of my height? Well, it looks like I had to do f of something. It looks like I had to do a b minus a over n, but in fact I had to do an a plus a b minus a over n. And then I found that height. And then I had to do, well, let's just stop there. So a plus b minus a over n. Now I'm not done yet. This is for a right Riemann sum. Oh, what's that? You don't know what a right Riemann sum is? A right Riemann sum is the right-hand rectangles. We call them a Riemann sum because we like to be fancy. Okay, now, how do I get the rest of them then? Great question. Okay, well, the way you're going to do that is, again, with a here, we added a b minus a over n. Okay, that was nothing. Now, in order to get to the next one, to get to the next rectangle, I still have to start from A, but this time I have to add 2b minus a over n's. And to get to the next one after that, I have to add 3b minus a over n's. So the number of b minus a over n's is changing. What could we call that? We could call that I. Right, we could call that I. So we put an I there for b minus a over n times I to indicate the ith rectangle. The ith rectangle? What is this craziness? Okay, voila. This is the coolest part ever. Now I'm going to add them all up. So I need a sigma. We're going to do from I equals 1 to n of. Here we go. We have f of. I'm so excited. I am pumped. Because honestly, this is the coolest thing since sliced bread. Okay, that's your sum to find your area given any number of n rectangles for any function. That's pretty cool. Like, you can't tell me that that's not cool. Okay, now, here's where we're going to go with this just to make sure you're clear. This part, f of b plus f of a plus b minus a over n, that's called the height. So we have the height, we have a width. Notice the width is always staying the same. It's uniform. So the width is not changing at all, but the height is. That's why we have an I there. And why do we have a summation? Well, we're summing because we're going to keep getting all of these rectangles added up. We're going to add up the areas of all these rectangles because, again, when we multiply height and width together, we get the area of a rectangle for I rectangles. Okay? Okay. Okay, now let's do the fun part. So what is our width? Well, our width, let's say that this is A, this is A. Let's say that B is 2. It is 2. It's B. Okay, so the width is going to be 2 minus 0 over n, which is just 2 over n. The height is going to be f of A, which is 0. Oh, that's silly, Mr. Lakin. F of 0 plus 2 minus 0 over n. 2 over n I. And again, that's going to allow us to move to each rectangle because that height keeps changing. So that's going to be f of 2 over ni. All right, we got it. That's it. So here's what we're going to do. We're going to sum them all up. Go away, cough. Okay, now f of 2 over ni. Well, f of x was equal to negative x squared plus 5. So f of 2 over n I is equal to, oh boy, negative 2 over n I plus 5, which is equal to negative 4 I squared over n squared plus 5. Okay, so now we have I'm just going to plug that in over here. So the summation of negative 4, so I did some side work, squared over n squared plus 5. Now this was all of f of 2 over ni. So I'll just write that up here so you're clear. This is f of b minus a over ni. Not entirely true. Let's be a little bit more thorough. Okay, good. So that's what this part is. And then we have to multiply it times the uniform width, which was b minus a over n, which was 2 over n. And let's just see what we get here, because we have some formulas for this. All right, so we get, let's see what we get here. Okay, we could break up that summation into 2. If you're not into that, you feel free to skip ahead. Just make sure you're getting it right. Okay, we got negative 4 over n squared and I squared plus the summation from I equals 1 to n of 5. And then remember, we're going to multiply all of this times 2 over n. Okay. Mr. Lakin, it sounds like you're getting a little bit crazy right now, a little bit manic. Yeah, I usually do when I'm really excited about math and I'm sick. Okay, negative 4 over n squared. What's the summation for I squared? I remember. N times n plus 1 times 2n plus 1 over 6. Yes, go ahead and ask your question. Oh, do you have to know those formulas for the test? Yes. Okay, now we have plus, the summation here is just 5n, and we still have to multiply this by 2 over n. Okay, let's see here. Now let's distribute the 2 over n in. Remember in the last video that I made for my class, I said that, because I wasn't here, I said to just leave that 2 over n until the very end. So now the 2 over n is going to come into play, and I get negative 8 over n cubed times n plus 1 times 2n plus 1 over 6 plus 10n over n, which is just 10. And that's it. This will be our formula, n plus 1 over 2n plus 1, all divided by 6n cubed plus 10. That is our formula for n rectangles. Oh my gosh. Wow, that is awesome. What's missing? Oh, what's that? I didn't quite hear you. What's missing? A limit. Now, the problem didn't ask us for this, but let's just see what happens if we take a limit. What should we take the limit of? Well, I'll write it up here. We'll take the limit as n goes to infinity. What does that mean for the problem? That means that I'm making an infinite amount of rectangles. I'm giving myself an infinite amount of rectangles, because when I have an infinite amount of rectangles, let's just go back to your Schoology GIF here. When I have an infinite amount of rectangles, take a look at this little GIF. You can see, come on GIF, work GIF. Okay, there we go. You can see that when I have an infinite amount of rectangles, the widths get so small that eventually they kind of just fit into the curve. And that's exactly what we want. That's the coolest aspect of it all. So let's take the limit, even though the problem doesn't ask us for this. And I'm going to show you one more cool thing. Okay, n goes to infinity. Limit as n goes to infinity. All right, and then I don't know if Ms. Schwartz is going to get mad at this one. She might. Okay, limit as n goes to infinity. Okay, let's see here. Limit as n goes to infinity. Okay, so let's see here. For this top one, we have negative 8n times 2n. Remember, I don't care about that extra part, the plus 1 I don't care about, the plus 1 I don't care about. So that gives me negative 16n cubed. Now negative 16n cubed over 6n cubed is going to be negative 16 over 6, which is negative 8 over 3. So I have negative 8 over 3 plus 10. Well, that's going to be 22 over 3. That, my friends, is the exact area between the curve and the x-axis, a problem that has haunted mathematicians for years. Da, da, da. Okay, that area is 22 thirds. Here's the cool part that Ms. Schwartz may not be happy with me showing you. Here's the shortcut. Remember how in derivatives we had a very long way of doing it, and then we got our shortcuts to make things a little bit relatively easier? Well, we have shortcuts for rectangle sums too, Riemann sums. I'm just getting the equation here. What you're going to be doing next week, I think it's next week, is this. This is the symbol that you're going to be using. If you look ahead in your packet, you'll see it all over the place. It's what's going to dominate your life for the rest of your years. It's called the integral. I'm not going to explain my work here. I just want you to see how much simpler it is, because that makes me giggle. Let's see, so that's negative 8 over 3 plus 10 minus 0 plus 0, which is, oh, look at that, negative 8 thirds plus 10, which was 22 over 3. Wabam! Have a good day. See ya. Wait, how do I shut this off? Oh, okay. Let's sign off here. Okay.